our next speakers, as we're getting set up, we'll continue on a relatively related topic, looking at where our allotrope technology can help us in the method space, looking at taking all the compendial methods that we're familiar with from USP and digitizing them using ASM to help us from electronic document to executable method. So I will turn it over to Christof.
Great. So from ex-Osthus to ex-Osthus, next talk. We're between you and lunch, so I try to make this entertaining and short. The reason we are here together on stage is that USP and ZONTAL share some core ideas about how to share data, how to give information from one hand to the next. And we have the idea of we would like to turn our data into real corporate assets. And this is when we're talking about methods, this is a real thing. Like this is a real asset, your method that you're using and reusing. So this is something that we have been working on, and this is really confusing. This is the idea of having a methods hub, a repository for methods, was born a few years ago, and I will talk about this a little. It's a Pistoia Alliance initiative, and that worked with ZONTAL in the middle, and you will understand after a couple of slides what that means. The next idea was, okay, we have to focus, we have to start somewhere, like methods for what, and the idea was to start with chromatography, and we integrate methods from chromatography to chromatography instrument, from CRO to the pharma company, and so on. So ZONTAL has over the years created, in parallel to this methods hub, an entire chromatography solution, and then Kyle will take over and show you how we actually get to these methods. And this is the USP part. So just quickly, and we have created this slide, which takes a long time to come up. So now it did. We have created this slide. Really, we've started with this internally, discussing, okay, what is really this? What is the value prop? What I mean, the people who are receiving methods from somebody or reading methods in an article, they know how to set up the method on their CDS and how to translate that into their own science. There is nevertheless some interpretation necessary from step to step. So I need somebody who actually knows very well what the instrument can do, and then set up the method accordingly. And this can take time, and that's one thing that is of interest always, but is of course something that also need troubleshooting when it doesn't work. So why does it work at the CRO? Why doesn't it work here? Why does it work for them in the procedure, in the paper, and I cannot replicate it? So all of these things are there because there are some hidden settings of the rather complicated instrument can just be not discussed in that method. So it's just saying, yeah, it's there. And every instrument could be a little bit different. And then you can have, of course, people who know about these and who can change them and so on. So that is special knowledge that these specialists can do, and then they can run that method. They can make that method work. But this is all taking too long, and initially Merck and GSK came together and said, okay, we're going to change this. We would like to have a method transfer that involves a digital method that we can just take from one company to another, from one instrument vendor to another, that actually makes sure that all of these, or none of these settings are hidden. And so when you look at the digitalization of the lab, this is one thing that is not necessarily that this is not massive amounts of data. This is not super complex data, but it's extremely valuable data to know which method you ran and which version of your method you ran to produce these outcomes. So the idea was we create a method, a digital method that you can upload to a server and somebody else can download it, and it doesn't matter on which instrument vendor or which vendor instrument you actually run that on, and to actually be able to recreate the measurement. So that was the value prop why this was started, and there are of course a couple of ROIs to that and a couple of benefits to it. And this is not only these hidden settings, which are of course tedious to click through and have to know at your waters where to switch them on, off, or change them, and then also on the Agilent machine and or the Agilent software and so on. So these are all the things that we can now make sure that they are transferred from one method to the next, or by a method from one instrument to the other. But also there are manual settings, and this just takes long. There's error. There's just always error involved, and this resolution of failures that I talked about when it doesn't work. How do you get to the real root cause? This is something that it can at least reduce. And there is another reduction, and we heard that now a couple of times. ZONTAL, as well as many other softwares in this field, is of course GXP compliant. You can validate it. Everything is working with audit trails, and you can document everything. And as soon as you take the human error out of your workflow, because you're using a completely digitized workflow, your validation effort actually goes down. And this was one of the things that Merck and GSK were discussing. It's published, so the paper is out for that, and there are many talks that we gave or webinars we gave around that. So the idea was, like, I have a method, this method, and Kyle will talk about that, has assays in there. These assays we can pick apart, we can digitize, and the methods hub itself talks to the CDS system and makes sure that these translation errors are not done. So, and this is really the core of it all. And I don't want to take you through all of these parameters that we actually map in this right now. They are at the end, and when we share the slides, you have the full list there. They are also in the paper to some extent. So this is the actual list that we currently use from the ontology with the PURLs, and that, as I said, these are in the end of the slide presentation. So what does that mean to have a method in allotrop format? So it's not only that we map the parameters to the ontology, we also would like to standardize, of course, across instruments and vendors, and make sure that we have a driver to actually translate this allotrope method to the CDS again. So this translation is also part of that bigger initiative, so that we not only capture the methods and make them ASM, but also make sure that we have something that once the method is downloaded to the CDS, that actually it is in the right format so that it can understand it and the instrument can understand it. And so this is something that, well, we started with ADF because it was many years back. The ASM model is much more suited for that because we have a more or less human readable version of it. So you can actually look into the JSON file and find your settings and make sure, even if we have a nice viewer for it, but of course you can just use your text, your notepad or whatever to look at it. So these are the things that we can now have and share with colleagues, with CROs, with partner companies, and this is extremely, that's an extremely positive thing that we could take it from ADF and really put it into ASM now, and this is what we will show later on as well. So just to quickly go through that, as I said, we have, this is an entire Pistoia Alliance project. And so Merck and GSK said, okay, we would like to transfer the methods and see what's happening. And they could do, that was the first thing that they did. And from Agilent to Agilent, from Merck to GSK, that worked pretty well. It's a little bit off, but that's something that was totally anticipated. The second step that they wanted to do was transfer the methods from OpenLab to Empower. That worked extremely well. There's a little bit of difference because they used different lots for their standards. And then the third step was, okay, what do we do when we actually transfer between different control software, different instruments, and different companies? And that looked pretty similar to the first one, and they were happy. And then the analysis there was, well, they had different well volumes too. So they actually, that's why they're a little off. So that's easy to understand once you see it. But yeah, so it's really, this was the foundation for all of the idea to have one thing in the middle that keeps and stores and sends and receives methods. And that is ZONTAL in this case. So we have ZONTAL platform, the ZONTAL platform in the middle that not only takes care of the data collection and the sending of the sample lists from an ELN to an instrument, but also now is able to send the entire method, and then be consumed by the CDS, translated into the right format so that the instrument understands it and the data is coming back. That's why we have two lines for each of these instruments here. So one is going in and one is coming out. So it's bidirectional. And of course, inside ZONTAL, you can then view your data as well. So you can not only store it, but inside ZONTAL, you don't have to have a specific viewer. You can actually go, especially if you load old data into your historic data into ZONTAL and make it fair, you can still, of course, view the data inside ZONTAL and download it if you want to, of course. So this is what is currently already working. This is not a future sci-fi thing. This is actually what we have built out of this methods hub and out of ZONTAL itself. So we can actually feed the method to an ELN. Then you can, in your ELN, start a new experiment and include that method. And then you start an analysis request. And the analysis request goes again through ZONTAL to the instrument or the instrument software. You run your analysis with the method, the sample list, on your instrument, ZONTAL takes back or grabs back all of the data and even then sends whatever you would like to have back into your ELN. So if you have a sample list in your ELN, you might want to have measurements for these samples in your table inside the ELN. And this is all orchestrated under the hood by ZONTAL. And the interesting piece is the scientist will not even see ZONTAL in this case. The scientist does what the scientist always did, take a template experiment and run it. And the good thing is the sample list already appears automatically on the instrument. And by the time the run is over, the scientist goes back to look at the ELN, the results are already there. And of course, there are barriers of like people say, no, we don't want to have that. And I heard it before. We would like to have a pool. Fine. ZONTAL has an alert as well. So people can be alerted. Your run is ready. Your data is ready. Please download it. Push that button. Also doable. And if you made a tweak, if you did actually change something, you can see, of course, because you can send the method back from your instrument, you can actually see that this is where the changes are, because ZONTAL has the original, knows what it sent there, brings back the actual method, and you can actually, of course, then see the diff between the two inside ZONTAL, and that is, of course, very beneficial of looking when you're looking back. What did we do? And before I hand over, I would like to introduce the way into ZONTAL for methods, and this is what Kyle will talk about in a minute. We eliminate, of course, also the issues of the manual transcription of these methods, because we have created an NLP engine that translates monographs to methods that are then stored in the methods hub. And that's actually, I think, what you will show.
Yep. Thanks, Christof. All right, so thank you to ZONTAL for the work that you've done in working with us, and thank you to Merck and GSK for really starting the Methods Hub project. USP has built off of that, and we think we've got an interesting extension to what you guys have already built. So thank you very much for putting that together. As Christof showed, a lot of the foundational work was done there. So USP initiated a new division called Digital and Innovation about 5 years ago. And one of the projects for that Digital and Innovation team where I sit is the concept of digital documentary standards. How can we take monograph information or general chapter information and enable that in a digital laboratory, in a modern digital laboratory? And I want to start out with a little bit of a history lesson on USP. Because it all relates. So USP is over 200 years old at this point. The first version came out in 1820. I doubt anybody still has that on their bookshelf someplace. If you do, I'd love to see it. You guys might. You never know. So I think Merck actually probably participated in the initial founding of USP. But 200 years ago, a monograph was very different from what a monograph is today. On the left-hand side, I've got a capture of the Peruvian bark process in the 1820 USP. You know, an apothecary may have gotten a crate of bark from the Amazon, and they needed to extract it in alcohol and water and reduce it down and give you a cure for malaria, right? You know, over time, we no longer have apothecaries making that anymore. You may have a compounding pharmacy, but they're not making the original compound. The industry changed, and we moved into synthetic chemicals and synthetic APIs. USP, of course, evolved with that. And on the right-hand side, you see a modern monograph for quinine sulfate, the same active compound that would have been in that Peruvian bark. So we've kind of moved through that. We've evolved with the industry. We try to do that. And again, the industry has changed. You know, we've talked a little bit about digital transformation, Industry 4.0, Pharma 4.0. I won't ask you to raise your hands because everybody has already raised their hands on those topics. So USP is also evolving in this space. And again, if I go back to that 1820 USP book, on the right-hand side, I've underlined a couple of things. And this is from the preamble to that 1820 USP, is that we need to be compatible with the best knowledge of the day, and we need to be accepted by the people who we intend to use it. That's very, very important to us. And as these laboratories are changing to digital, how do we evolve to fit into that space? So one of the first things that we started to do in that conversation was to go out and ask you, what would help? How could you better use USP? How could we improve our product to be able to help you in the laboratory, and especially in that digital laboratory space? So these are some of the questions that, or the answers that we got back when we asked that question. And they really break down to, we'd love to do it, but it's hard. We don't have enough resources to build out the potential 4,000 monographs that are in USP and 6 or 8 tests that are in each monograph. That is tens of thousands of tests that we would have to build. We can't validate it. What happens when you change it? How do we keep it up to date? And it boils down to the comment that's in the bottom right-hand corner, which is essentially, couldn't you do this for us? Couldn't USP publish your content into an electronic laboratory notebook or make it easily available to a chromatography data system like Christof has been talking about? And that's the project that we're trying to start to work on. And we'd love to work with the industry and the vendors on those types of projects as we go forward. So our labs are just like your labs. And in fact, many of our scientists have come from your organizations, and many of our scientists returned back to your organizations. We've gone through the same kind of evolution that you've had to go through in your laboratories today. We were a paper-based lab, just like you were. We went through the whole thing about let's put everything in spreadsheets. And what do you mean I have to validate a spreadsheet? How do I do that? So we did all the validated spreadsheet thing. Today, we're running a single commercial ELN and a single commercial chromatography data system, similar to what you're doing. But in this digital journey, we begin to think, how can what we did in migrating our labs help your laboratories? And so we're trying to see how we can take the procedures that we're already using electronically in our laboratories and move them into your systems. So the work that ZONTAL has done has really helped us in extracting out some of that content as we go forward. So what if there were a truly digital and executable version of the USP that was based on the USP standards, that was official USP content? It was vendor neutral and it was fair and easily implemented inside of your ELN, your CDS, whichever electronic data system you're working with, and it stays up to date with changes. As we have a new monograph come out, we update it for you. You can choose to pull it down when you're ready to accept the change. Is that something that would be useful to you? There's a few head nods, so that's a good sign. The next is the video. So I will probably pause it at one point in the video. The beginning of the video, about 2/3 of it, is really just showing you the accuracy of the transcription, starting with the monograph, going into the ZONTAL tools, making sure the data is correct, and then down into our CDS. So I'll pause it at one point, which is really where we kind of see the background work that we could pre-build for you, and then maybe what the user interaction is at the end. So we'll go ahead and pop into the video here. Take a look at a new tool that we're working on here at USP. We are currently undertaking a project that will allow us to transfer monograph content directly into your laboratory systems that you may be working with today. So I'd like to take you through how that's done and hopefully get some feedback from you at the end of the process. So to take you through how this is set up, I have a tool here on the left-hand side, which will allow me to convert XML formatted monographs directly into files that are readable chromatography data system. And that is done by creating what's called a monograph archive. And I'm going to drag over the ezetimibe API monograph into the system, and I'm going to submit that up into the conversion engine. And we'll see that starting to process. It went from new to transmitted, and it's doing some calculations in the background, versions in the background. It's now created it, and it's going to be creating the files next. I'd like to take a look at a little bit of the background on what ezetimibe is while that conversion is ongoing. So this is the ezetimibe monograph in the USP NF today, and you're probably familiar with the structure of these. There's a variety of tests that are within a single monograph, so like an API, where I would identify the compound, in this case by infrared spectroscopy. I would do an assay of the raw material, the API, to make sure that it's pure. And this is one of the reasons why I've chosen ezetimibe as my example, is it has a ternary gradient structure, which is a little bit different from some other ones that are out there. We have 3 different mobile phases changing over time. And I also have 2 different lengths of detection, 215 nanometers and 248 nanometers. My detector is set at those wavelengths. I have a flow rate of 2 mils per minute. I do not have a column heater in this particular example, but some of the other monographs would have column temperatures or other settings specific to the detector that they're working with. So coming back over to the conversion tool, we now have the methods ready in a native format for the chromatography data system that we're working with. We're going to be transferring over the ezetimibe API assay method. That's the one we're going to be working with today. So I want to look inside of that method right now and see how it's structured so we can show you what's going on and how these are broken out. So there is a viewer within this tool that will allow me to examine the method parameters of this particular instrument control method that's been created by the system. Unfortunately, sometimes it takes a minute for it to do the conversion. But here we have my auto sampler. In this case, it's recorded that there's a 60 microliter injection volume. The pump, there are mobile phase A and B settings. So at the first time point, which is at 2,220 seconds, I'm at 10%, 24%, 66%. So we see that ternary gradient over time. So the pump parameters are in the system. The diode array detector, I have 2 wavelengths at 215 and 248 nanometers. So all of the parameters necessary for this process are now within the conversion engine and are in a native format transfer over to the chromatography data system. So that's the next step that we'll take. And again, that is done from an ingestion page. In this case, we're going to create a new method request. And this is, I'll need to type it in, ezetimibe. And I'm using the API assay method. I'm going to give it a name for what it will appear as in the chromatography data system. And I need to type in username, and this is just demo. And we are going to submit that over to the chromatography data system. So we see it created, and this will go through a couple of more steps while it's moving over to the system. So we'll give that a minute. Okay, let's go take a look in the chromatography. Take a look at a new tool that we're working on here at USP.
Okay, so I just paused it real quickly there because that's the transition from what we could pre-build to what the final interface may be. So once I get into the CDS, all I would need to do is download. So you're seeing what we have in our laboratory. So, you know, USP has been a water shop. We have Empower, we have New Genesis. That's what we're running today. So that's what I'm working from. But as Christof showed, we could work with any of the CDS systems that are out there. We can move back and forth. This is just what's in our lab. So all of that preparatory piece was really just showing you that the data is being transferred correctly. As I get it into Sorry, I lost my place again. Get it into the CDS. This is the final step.
You're not sure.
So I'm going to go back into the project I was just in and remember that this was empty. It's a little lag here, sorry. And let's go and import a method into the system. This then opens up my import tool, and here is the method that was transferred over, the ezetimibe API assay. It's going to be saved in the system as ezetimibe API assay. And I'm going to tell it to use that HPLC default parameters setting, and we'll import. This gives me one successful import, so that's a good sign. My assay instrument control parameters are now in the chromatography data system, and let's open it up to take a look. This is an error I expect, no problem. As I mentioned before, the range of the data array detector is 210 to 400 nanometers. Nothing would have changed there. But I do have now successfully imported 2 different wavelengths of detection. My pump is now correctly set at 2 mils per minute. And I see the gradient table is here. I can expand that out and we can take a little bit closer look. So over 100 minutes in this case, it will go from 66% A, 24% B, 10% C through a gradient change. And then it will reset itself back to the initial conditions to be ready for the next injection of the system. The auto sampler, as I mentioned, there were no parameters set for the column temperature of the auto sampler, nor was there a parameter set for the accessory column heater. So in USP laboratories, when there's not a temperature set for a column heater, the default temperature, and we had set that in the default template. So we've now shown a successful transfer of the method from the monograph all the way through into the chromatography data system.
Okay, so that's the little demonstration that we had done there. The next step for us will be to try and structure the other pieces and parts of a chromatography experiment, how to make the mobile phase, how to make the standards, dropping those into an ELN. So we'll be working with ZONTAL on that in the next steps. But really the first was getting those instrument parameters out and showing the capability to take it from a printed document or a PDF, non-structured format directly into the chromatography data system. So that's what we've been working on. Hopefully it's useful to you. And if there's any questions,